All right, here we go. Video 7, the last video. So there's not really going to be a mastery check for this video, but a lot of the questions on your test are going to look like this, especially the last couple that we do. So this is definitely important. All right, so there's just going to be some miscellaneous transformation questions using everything that we've learned from the first 6 videos. We are going to add one thing to our success criteria, all right? But we need to rotate a figure around a center of rotation other than the origin, solve for missing angles or sides given a sequence of rigid motions, define invariant and variant points. And what we're also going to do is we are going to map figures onto themselves. So map a figure onto itself, and we'll talk about that in the third example. So we're just going to jump right into examples here. So graph triangle BAD, all right, and perform a rotation around the point 90 degrees. All right, so this is going to be a little different. So the first thing I need to do is graph my 3 points. So I'm going to graph all 3 points here. Okay, and we're actually going to rotate them not around the origin, so the formula is not going to work here. We're actually going to rotate them around this point 1 right here. Okay, so what's going to happen is this figure is going to rotate as if that little red dot is the center. So the way that we do this, right, our first step is we're going to draw a new axis, or draw new axes. Okay, so I'm going to make a fake y-axis here, and I'm going to make a fake x-axis here. The reason why I'm doing this is because then I can use my formula to solve this. So you draw axes, and it's going to be through the point that we have. All right, and step 2 is we're going to make some fake points. Then we're going to use our formula, okay, and then we're just going to recount. All right, I'll show you what that means. Okay, so if I was talking about the fake axes, right, so my fake coordinates here, so what is the coordinate of the fake point B? So based off the red axes here, I would go to the right 1, down 2 to get to B. So it's going to be 1, -2. My fake A, again, is down here based off the red, is going to be over 4, down 4. So it's going to be 4, -4. And my point D is going to be 0, -5, because it's right down here on my fake y-axis. Then what I'm going to do is, since I'm creating a new set of axes here, this red point is my origin, and I'm rotating around this red point. So I can use the rotation of 90 formula, which we know is to switch these coordinates and negate the first one. So my B prime, my A prime, and my D prime here, I would have 2, 1, 4, 4, and 5, 0. And the way that I would do this is I'm going to graph this based on the red set of axes, the new one that I have here. So I'm going to do, I have 2, 1, which is B prime. I have 4, 4, which is A prime. And I have 5, 0, which is D prime. This is my new triangle here. So I got my axes, my fake points, and my formula. Now what do I mean by recount? So recount, we're going to recount based on the old axis. So I'm going to get rid of these. And what you'll see is now I can recount what my actual points are. So my new points, okay, I'm going to find what B prime, what A prime, and what D prime are. All I have to do is count them out. So we got 1, 2, 3, 1, 2. We got 3, 2. A is going to be 5, 5. And D is going to be 6, 1. All right, so that's one way to do this. All right, if you can think of a different way or you look it up, there's probably some other formulas out there. This is the easiest way that I find to do it. All right, so if you have any questions, let me know. You don't really see this too often where you see this type of question asked mostly. It's usually a choice in a multiple choice question. All right, and we'll actually see that when I get down into example 3 here. All right, so let's just move right on to the next example. This is more like what you're going to see on your test or your Regents exam. All right, given that triangle ABC is mapped onto DEF after a rotation around point P, solve for X. Well, two things going on here. One, rotation. So we know that it's a rigid motion, and since it's a rigid motion, okay, we know that ABC, triangle ABC, is congruent to triangle DEF. And we talked about we would stack our letters on top of each other because they're talking about side D to E. And side D to E lines up with side A to B. So these two, we know, since it's a rigid motion, they're congruent. They're exactly the same. So I know if they're congruent, I can set 2x minus 1 equal to 16 and solve. I can add 1 on both sides. 2x equals 17, x equals 8.5. All right, so the key to this question is just knowing that a rotation is a rigid motion, which preserves distance. So that means that AB and DE are going to be the same length. So we set them equal to each other and solve. All right. Example 3 here. All right. This is important. This multiple choice question comes up a lot. You're definitely going to see it on your test. So invariant points, points that do not change under a transformation, right? And mapping figures onto themselves. So when a figure undergoes a transformation that leaves the same image, this question comes up a lot on the regions. It comes up at least once, or it'll definitely come up on the test. So which transformation would not map the rectangle onto itself? So 1, reflection over the x-axis. So if I'd flipped these 4 points over the x-axis, all right, what would happen is this point would wind up here, 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 and we'd have the same exact rectangle. Okay, so it would map the rectangle onto itself. So this is not the correct answer. We want something that's not going to map it onto itself. All right, let's look at the next one. Reflection over the line x equals 4. So again, where is the line x equals 4? Line x equals 4 is right here. Okay, remember my x equals lines are always vertical. Now again, same thing. If I were to flip this triangle over this red line, this point would wind up right here. This point would wind up over here. And same thing on the other end. So we would have the exact same rectangle. So it is not going to be this choice right here. All right, choice 3 says a rotation of 180 degrees about the origin. Now, if I took these points and I rotated them about the origin, I would actually get a rectangle over here. And it would look like this. Now, if this was the rotation, the rectangle was not mapped onto itself. It's actually mapped right here. So it's 2 totally different rectangles. Therefore, choice 3 is going to be the correct choice. Now, if we take a look at choice 4, just because we might as well look at it to make sure that we know what we're doing, rotation of 180 around the point 40. Point 40 is here. So think about flipping the paper upside down. If you flip this rectangle upside down around this center point here, the rectangle is not going to move. It's just going to kind of spin around in that same spot. All right. So last question. We're going to do one more. Here we go. This comes up as a part 2 every once in a while as well. So the graph below ABC has coordinates of A, -9, 2, -6, 6, and -3, 2. And RST has coordinates R, -2, 9, 5, 6, and 2, 3. So it's asking, is ABC congruent to RST? Use the properties of rigid motions to explain. So first thing we want to look at here is we want to see if we can map ABC onto RST. So A needs to map to R, B needs to map to S, and C needs to map to T. So in order to do that, it looks like we're going to have a reflection here, probably over this line. This is the line y equals -x, and I told you this comes up every once in a while. So what I'm going to do is I'm going to stack the points on top of each other, and we're going to talk about what's going to happen here. All right, so A is -9, 2, B is -6, 6, -6, and C is -3, -2. Then we have R, which is -2, 9, S, which is 5, 6, and C, which T, I'm sorry, which is 2, 3. So if we remember, how do we get from A to R? So like, what's going on? What transformation is happening? Well, to me, it looks like this reflection, because what's happening is the points are switching and we're changing the sign of both. So if I do that to A, I would get -2, 9. If I did that to B, I would get 6, 6, And if I did that to C, I would get 2, 3. So you should notice that there's a problem here with B and S. These 2 points do not line up under a rigid motion. So if they don't line up under a rigid motion, if all 3 of these points don't line up, then they're not congruent. So the way we would write this is that ABC is not congruent to RST because there is no sequence of rigid motions that map ABC onto RST. All right? So this is kind of the opposite of what we've been doing. Most of the time I would ask you to show that they're congruent or prove it this way, but this is one of those cases that I was talking about in video 6 that does not work out. So if you can't find a sequence of rigid motions that maps these 3 points onto these 3 points, then they're not congruent, and the answer is as simple as that. They're not congruent because there's no rigid motions. All right, so you got to make sure that you be careful and you check both of those to make sure that it works. All right, so again, fill out any questions, give a short summary. These practice questions are super, super important in this packet because you're definitely going to see questions like this on your test. All right, so we'll go over this on our review day. Remember, no mastery check for this, but make sure the practice questions are done.